basically we showed the way for building highly performant and highly reliable devices and go directly to the arteries of the server.
Hello and welcome to episode 73 of Great Things with Great Tech, the podcast highlighting companies doing great things with great technology. In this episode, we're talking to a company with a forward-thinking approach to file and data management across diverse storage solutions, a company that has become an indispensable tool for businesses everywhere looking to solve the problem of data sprawl, storage utilization, data mobility, and application continuity. That company is Hammerspace. And today I'm joined by David Flynn, the co-founder and CEO at Hammerspace. Welcome to the show.
Thanks for having me on, Anthony. Glad to be here.
Excellent. Awesome. So just before we kick into Hammerspace, as a reminder, if you love great things with great tech and would like to feature in future episodes, you can click on the link on the show notes or go to GTwGT.com. As a reminder, you can go to the podcast platforms, Apple, Google, and Spotify. Follow and subscribe there to catch up on all past and future episodes, and also on YouTube at GTwGT Podcast. Hit the subscribe button and the like button and get all future episodes and past episodes, more importantly. And with that, let's talk about Hammerspace, David. And just firstly, let's talk about you and where you've come from on your journey in the lead up to founding and now being the CEO of Hammerspace.
You bet. Well, if we started from the beginning, it would be as a hobbyist 13-year-old who taught himself programming on a Commodore 64. I later had to confess that to Steve Wozniak that we grew up a little too poor. My dad got a PhD in physics, and I had a lot of siblings, so we grew up a little education and child poor. But that's where it started, was as a hobbyist.
Can I just say, I had a Commodore 64. So we're in good company here. That was my first computer, and that's the first computer that I used to program. I remember getting a magazine from a bookstore, and I typed in the code, spent 3 days typing it in, and then when I hit go, it didn't work. And that's when I knew I didn't want to be a coder. But that said, I love the Commodore 64 platform, so let's not ditch on it too much. It was a great machine.
Yeah. So that's where it started, but I was fortunate to grow up. I grew up in the Southeast and in Huntsville, Alabama, big in rocket science, and was around technology quite a bit thanks to my father there in the working in the space program, the Strategic Defense Initiative. But I ended up, my junior year in high school, I ended up working for Computer Science Corporation, building a flight simulator for an Army missile system.
Whoa! In high school?
In high school, yeah. I taught myself three-dimensional graphics and wrote software to do real-time wireframe rendering, and caught the eye of a gentleman who ran the Commodore users group, but was also a mid-level manager at CSC. So one day he invited me in and said, "You really got to come and talk to our team here, because we're going to be bidding on this contract to build a simulator for this Army missile system called the FOG-M, fiber optic guided missile. It had 32 kilometers of fiber that would spool out of the tail. The thrusters were actually on the side of the body, but that way it was unjammable, and you could, be 32 kilometers behind the front line and launch these things. But so I ended up writing software, in this case on the Commodore Amiga, for doing solid fill 3D graphics to, for a training thing. But so that was my passion to start with, was three-dimensional graphics. And that led into, I went to college, went to BYU, worked at a local firm that was in the noise monitoring business, built industrial microphones, and we had contracts with several major airports around the country. And that led to me building a graphics information system, a GIS system for mapping out flight paths of airplanes relative to the noise monitoring base stations around the airport. And in all of this, we used the Oracle database.
Okay.
And so we're going into crazy details on my career arc here.
Ah,
So,
it's fascinating. Keep going.
so, so I ended up, one of the kids that I was in college with, his dad had done marketing for Oracle in the very early days. Remember the stunt with a tank driving a tank down the road, Larry Ellison?
I have seen that. Yep.
Yeah. Well, so we interviewed with this burgeoning team at Oracle who was going to build a web browser right before the war broke out between Microsoft and Netscape. Larry Ellison had set out to build a web browser. And then it became clear that nobody was ever going to make money building web browsers. So the team that I had become part of at Oracle, within 3 months, had got spun off into the Network Computer Inc. Larry Ellison's go at poking Microsoft and Intel in the eye by introducing a non-x86, non-Microsoft OS smart terminal. You might remember the attempt around smart terminal stuff.
Yeah.
And that ended up, we built stuff based on NetBSD, embedded, the brains there, but it became apparent that corporate smart terminals and thin clients were not all that big of a market. And so we switched focus to interactive TV, and that became Liberate Technologies. And that's where I was a founding engineer, you could say architect. I built an office of about 30 people out of Salt Lake City, engineers that were part of this company that was NCI and then later Liberate. They had a successful IPO, and then the bubble burst and the dot bomb. And some of the engineers that I had hired said, "Hey, David, you got to come to this company that has been doing high performance computing by the name of originally Alta Technologies, but later named Linux Networks."
Linux Networks.
So, here I am, a software guy, three-dimensional graphics and database and OS level stuff. And the team there said, "We need you to become an expert in this newfangled thing called InfiniBand, high performance networking."
Okay, yep.
And so I built the first large-scale clusters that used InfiniBand for mostly for U.S. Department of Energy, but later private organizations. So the first 100 node, the first 1,000 node, and the first 10,000 node Linux cluster that used InfiniBand.
Yeah.
And that's where I became friends with Yal Waldman, the CEO there at Mellanox, because we basically helped InfiniBand find a home in the world because it got orphaned early on by Microsoft and Intel and IBM.
Yeah. And just to cut in there, by a lot of actual companies that I've been around in as well in my last 20 years, as a hoster, I knew a couple of companies that took on InfiniBand as their main, network distribution system for quick storage and effective storage, because it was just so much better than everything else out there. So it definitely found the niche in certain areas, as you talked to.
It did. And in the early days, HPC was very good because there's a lot of east-west traffic, node-to-node traffic, because north-south is difficult because storage did not at that time really have very good performance. And it was around that time where I'm doing dream job of any engineer, building some of the world's largest supercomputers. And at that time, we built the world's second largest system called MCR. I think it was Los Alamos that did that one, or maybe it was Lawrence Livermore. But in any case, I ran into an entrepreneur who convinced me to leave that job and to go to a startup he already had underway, building a security device that involved embedded Linux on a tiny little thumb drive.
Okay.
Using NAND flash. And so here I'd been building these, big supercomputer clusters with massive, this was in the days of the Opteron and the early days of 64-bit processing. And then we go to embedding on a tiny little Power PC chip that's like 300 megahertz running Linux. And by golly, if this tiny device didn't seem much more responsive than these huge server nodes that you would stack in the thousands to make a supercomputer. And that pricked my interest. I'm like, what's going on here? and realized that the flash devices that by then everybody had been using, for thumb drives and for, iPods and even smartphones that had just come out. But those flash devices, had crazy high performance. And when I looked at, well, why aren't people using these in the server class world, like the supercomputing world I'd just come from? I found that the SSDs that were made, solid state disks, were pathetically slow. They were
Mhm.
slower than regular hard drives. And I'm going, wait, to get to these capacity points, you have to have hundreds of these chips in a package. And yet they're getting not even the performance that I can get with one of them in a tiny little embedded system. So what's going wrong? And hence the idea and founding of the company Fusion IO and
And I
putting
think
Flash on PCI Express.
that's why I'm smiling so much here for people listening to this. You can't see me smile, but I was such a geek fan of Fusion IO, and the Wozniak reference earlier makes sense now because obviously, he was a big part of that. But I was one of the guys working on servers and server farms for hosting when I
Mhm.
first got my first Fusion IO device that we put into the server to test out. Blown away. Like, it was like the most amazing piece of hardware that I'd ever used at the time, right? It was so groundbreaking. I remember spinning up a VM and putting it and doing a storage vMotion from
Everything's
a
so snappy.
from a normal, traditional SAN, and we put it onto this Fusion IO, and it all of a sudden, I blinked and the thing booted, and I was like, this is crazy good technology. So
Yeah.
I love this build up because it's like a cool journey, right? You've mentioned this parts of my career that have triggered, but it's all building up to Hammerspace. But keep on going. I mean, Fusion IO.
We're gonna,
Maybe
yeah.
just talk about being
Mhm.
part of that company because it was such a groundbreaking company and something that I think it created a lot of fanboys as well. It had that real
Yeah.
essence about it. So yeah, just give a little bit around that.
Well, we had great marketing. This entrepreneur, Rick White, who convinced me of leaving that dream job of engineer building supercomputers. And, when we decided to found, Fusion IO, we stood up there and said, look, the performance of a SAN in the palm of your hand. And people didn't believe us that you could have higher performance than a $1 million storage array in a device that could fit in your hand. And we undersold it more than anything because it was way faster than any number of disk drives. You can't fix latency through parallelism. It only gets worse. So this was crazy fast in comparison. And the basically we showed the way for building highly performant and highly reliable devices, and then showed that you needed to bypass the RAID controller and the storage buses and protocols and go directly to the arteries of the server. And what this company, Fusion IO, was way more successful than I would have ever dreamed. There was so much pent up demand, so many, let's call them wasted CPU cycles waiting for IO
Yeah.
but it was really difficult for normal folks to take advantage of it. Maybe if you had a database, maybe if you had a very large homogeneous web scale application like the big web monsters, and
Mm.
Facebook was an early adopter, Apple with iCloud was an early adopter,
Yeah.
Microsoft. But for normal folks, what was missing was a high performance file system that could truly exploit Flash distributed even down in the servers themselves.
Yeah.
Right?
Can I say as well? I think one of the things about Fusion IO that I remembered was cost was obviously something that you had to consider in terms of bang for buck. Understanding that it
Yeah.
was a lot more expensive than if you had like a SAN traditionally for obvious reasons. But then I think when I think about it, it was massively ahead of its time as well. That's the feel that I got for that
Yeah.
technology, and the uptake at that more commercial level probably wasn't there because of that step that people had to take to go, hey, if I'm going to run some VMs, what's the benefit of running VMs on this rather than what you talked to, which to more your point was more that high performance sort of scenario, right? Which you
Well,
could justify the cost.
what happened is, and we early on, as a matter of fact, the idea for Fusion IO came from a discussion about how to build high-density virtual desktops. At the security company, we wanted to be able to run desktops in a secure environment in virtual desktops. And that's when, I got to looking at, well, the only reason you can't put 10 times as many VMs on a server is because of IO constraints. And so Fusion IO was actually built initially to solve VM density by solving IO density. And but I realized that it was more general purpose than that and could solve databases and on a whole class of problems. And therefore we went for the more general solution of just acceleration, server acceleration, period. But we came across this tiny little company who was pre-integrating virtual desktops and virtual servers by the name of Nutanix. And we took them under our wing. They incorporated our product. And every time we came across a customer that said, I want to use Flash to get higher density, we said, well, you don't have to integrate it yourself. You can use this pre-integrated appliance.
I did not know
And
that there was this marriage between Fusion and Nutanix early on.
the same is true in the early days with Palantir. Palantir was an early adopter. You might be familiar with them, big on data and analytics. And they were an early adopter of Flash acceleration technology. But the truth is the tech was always destined. It needed to become commoditized and high volume and mainstream. And it was in the standardization of NVMe and now the NVMe connectivity SSDs are the largest dominant form of SSDs in the enterprise, and will be in a couple of years. They're anticipated to be nearly $500 billion a year.
Wow.
400 billion a year in NVMe flash. And so that's what it was destined to become. And now, of course, it's become much more cost effective as those technologies have gone to volume and
Absolutely.
the flash density has gone up.
When I consider, what I've got in my server running here, I've got a 2 terabyte NVMe, high-end NVMe disk, high write, and think about what that cost versus what the Fusion was, back in the day. It's actually, mind-bogglingly cheaper than that. But
that's right.
That's what we do when we advance in technology, when it becomes mainstream and the technology gets more accepted.
That's the beauty of Moore's law, right? Double transistor density. And with flash, it was actually faster than that, because you could not only pack the transistors, but you could put more bits per transistor with multi-level cell and triple level cell and so forth. So the capacity density of flash has actually been faster than Moore's law. And that means the cost per unit capacity has come way, way down. And of course, the bar was set for what kind of performance one should expect. And now, not all NVMe devices are created equal, but those that are done well get, similar performance to Fusion IO. I wouldn't say they're quite as performant, but, nowadays it's much more available.
Yeah. So then, Fusion IO, I think from memory, Fusion IO got sold off to or acquired by SanDisk in about 2014.
Correct.
So Hammerspace was about 2018, obviously, probably a few, maybe 2017, 16, where you started the idea. So what did you do between, SanDisk and Hammerspace?
I actually started building this technology in 2014 when I left Fusion IO.
Okay.
The realization was, if you really want to get the best from Flash, you need it local to the server. You don't want to suck it over the network. And so we need a file system that can aggregate decentralized data that's distributed across servers, or data that's distributed across third-party storage systems, and or data that's distributed across whole data centers. See, these are all three different scalings of the exact self-same problem: data locality in the storage devices, whether it's across devices in servers, across third-party storage systems or services, or across whole data centers. It's still a matter of how do we have a logical unification into a single global namespace while you still have a physical distribution across all of the diverse infrastructure that you might have in these different facilities. So logically unified, physically decentralized we needed to build a technology that was capable of doing that with data. It was the main reason why people found it hard to adopt Fusion IO, because traditional NAS kills your performance, right? Traditional NAS saps all of the potential and of delivering that. So you need a real parallel file system. You need a way to aggregate the performance of many flash devices into a single high performance environment that doesn't create a choke point on the network, as it were.
So, okay,
and so I left
yeah,
and
go ahead.
I left and I started the company Primary Data. And of
Primary
course,
Data.
having golden fingers leaving, Fusion IO, I was able to get VC funding and build Primary Data and acquire some of the technology and get the team together. But about 4 years in, I set the expectations with the VCs. So we're going to go after a really hard problem here. File systems have always been the most difficult part in software of operating systems. The operating systems have been defined in large part by the way they manage data on storage devices. DOS was named after it, Disk Operating System, and it was that FAT16 and later FAT32 and then NTFS file system that were kind of the defining features. And the file system went from sitting on a single disk to sitting on an array of disks to being in front of a storage array, or actually being embedded into the storage array, and hence you get NAS. Now the file system is shared across the network. But that architecture leads to the network becoming the choke point to get to that appliance. And NetApp, network appliance, was an appliance-sized version of a file system on the network, a file server. And so Primary Data set out to build a new type of NAS, not a scale-out NAS like Isilon or a scale-up NAS like NetApp before it, but a true parallel NAS. Because only then were you going to get the advantage of high-performance flash at scale, is to have many parallel, ability to talk to many different nodes at once in parallel. And so that was what we started building at Primary Data, was going to address that. And when the VCs got a little myopic, as they tend to, and we had a disagreement about where to go with the company, I wanted to pursue the bigger vision. I ultimately bought them out. And that's when we founded Hammerspace with all of the assets and technology from Primary Data.
Okay.
And that bigger vision was to not only solve the parallel access to lots of flash over the network, but also the managing of data across third-party storage systems and the access of data across whole data centers. So all three of those scalings of the same data localization problem, making it possible to have a file system that can literally span all forms of infrastructure, server flash, third-party storage systems, and data centers.
So and obviously want to extrapolate on that a bit, and when you're talking about that vendor neutral file systems, but that also includes object storage in the cloud. It includes everything that you can consider. If you look at the architecture document, which I'll link to in the show notes, you basically cover everything, right? And you've actually, when I look at that diagram, a lot of those vendors that you cover are guys that I've had on the show before, even as recently as my last episode with Backblaze, as an example. So it's a really interesting problem that, that story, by the way, in the lead up to Hammerspace was one of the best that we've had on the show. So thanks for that. There's a lot of great history there, right? But yeah, I think from that problem, the problem statement that you're trying to solve isn't one that hasn't been tried to be solved before. Because I've had other vendors on the show talk about the problem of parallelism and the network and the disk and the choke point. So what's Hammerspace doing differently to actually make that a reality?
Sure. So you could say that Hammerspace is the marriage of three technologies, two of which have never existed together before, and the third has never existed, period. And let me explain. So the first one is a parallel file system. a supercomputer class parallel file system, like the Lustre or GPFS or StoreNext or Weka, if you want a newer version of those same
I've
things.
had them. I've had them on the show as well.
So Hammerspace is a true parallel file system, like those. And not that those haven't existed before, they have, but we marry that with standard enterprise NAS and feature set. So it's NFS. NFS through and through, compatible, easy to manage, reliable. So we just make it super fast by making it parallel. And the marriage of these two things has been dreamt of before, but it's never been achieved. Folks had conceived of, including the guys who commissioned building the Lustre file system back in the days when I was in supercomputing. So folks like at Los Alamos National Labs and so forth, they wanted to see a standards-based parallel file system. But you ended up with these exotic file systems that have custom client software. They're, even though some of them are open source, they're still not actually built into Linux.
Yeah.
Consider how weird that is. They're open source, but they're not part of Linux. What does that tell you about the difficulty and the maintenance? They've never even made it into mainstream Linux upstream, right? So this ability to be both enterprise NAS, reliable, convenient to use, easy to use, those two things have never existed before, even though they had been dreamt of. And the net result of that is that you can get the maximum utility of your hardware. You've got the performance to feed your GPUs and CPUs, but you also have the convenience to where your researchers and your administrators, they're using stuff that's simple. I put the analogy here very much like my beloved InfiniBand. You heard my background with InfiniBand.
Yeah.
Back when I was doing that, by the way, I was a part of the creation of the Open IB stack that later became the Open Fabric stack. And we actually proposed the notion of data center Ethernet, or having Ethernet adopt many of the technologies that were unique to InfiniBand, end-to-end flow control, lossless packet delivery, but more importantly, RDMA capabilities. And we've seen over the years, many of those things get adopted into Ethernet with like Rocky, the RDMA over Ethernet technologies. And now with AI becoming a very mainstream thing because of the, AI is driving HPC into the mainstream.
Yes.
Thanks to AI, HPC is becoming mainstream, and yet people need to be using Ethernet. And high performance and RDMA capable Ethernet is picking up much of the business now because InfiniBand is still too exotic and the relative benefits have diminished as Ethernet has adopted many of those technologies. So you could say Hammerspace is kind of similar. We're using the architecture of one of these exotic file systems, but we have put it into the NFS standard. My team built the NFS 4.2 spec.
Oh, okay.
That came from a team here. My CTO is the kernel maintainer of the NFS client stack. So he's the guy who wrote the client in Linux. And so this has allowed us to put the sophistication into the client. And oh, by the way, it's been there since RHEL 7. RHEL 7 has a client sophisticated enough to use Hammerspace and a true parallel file system right out of the box. Wow. No customizations to the kernel necessary or anything.
I was going to ask, in terms of the architecture, like what are the components that are required for someone to go and actually leverage the Hammerspace parallel file system? And is it literally a software-based approach, or do you have to add a bit of hardware to it as well?
Not at all. As a matter of fact, this is one of the things that's been very attractive by some of the large web scale that are using us for their AI research. They can use their off-the-shelf Linux, not only as the client, unmodified, it doesn't take a custom client, but the storage nodes are just off-the-shelf Linux, serving the data over NFS. So in one example, one of our largest installs, they have 600 storage nodes, 100 terabits per second each on 100 terabit network. 100 gigabit networking. It does in aggregate over 60 terabits in total. So 100 gigabit networking on each node times 600 gives you 60 terabits, and they're able to achieve over 90% of that from
Wow.
their clients over Ethernet, and it's not even RDMA capable Ethernet. So when I talk about InfiniBand is overkill, so I mean, it is if you're trying to just get at that next 10%, but then having to pay a whole lot more than that in terms of the overhead cost and difficulty in managing. So this marriage of two things that have always been dreamt of being combined, but never have: enterprise standard NAS and high performance supercomputer scale parallel file systems. And we put those together, and that's a marriage whose time is overdue because of AI workloads and the need for high performance computing in the mainstream. But the third piece is what makes it utterly unique, and that's the data orchestration. The fact that we can sit data on any form of storage, file, block, or object from any vendor, and we can move the data across them from within the file system. So they're not copies, they're different instantiations of the same data. So you get that logical unification of physically distributed data, where that data can be distributed across any form of third-party storage system or service.
That's what I was going to say is the mainstream, right? That's the mainstream component of it, because you obviously talked about high performance compute, AI, which is becoming more mainstream. But from what I've seen in terms of that unified file system that you guys can provide to even just a remote worker on a laptop, that's the actual real beauty of it from a mainstream perspective.
Everybody needs data orchestration because everybody needs to incorporate cloud computing, and they need to be able to shift workloads around to support a geographically distributed workforce. So the old school adage of move the compute to your data is actually couldn't be more wrong. The compute is what has to be tethered to the real world. You have to rack and stack a bunch of silicon, and you have to power it with an electric grid, and that's at a fixed location. So it's the data that's virtual. It's the data that ought to be able to be moved. With data orchestration, that data can now move, and you can move the data to where you're going to do the compute instead of this thing of move the compute to the data. You're from the storage industry, so you've probably heard people use that all the time.
Absolutely. It's an interesting one because I think it solves a lot of issues that, from my perspective, I know that we had trouble solving when I was, on the other side, actually responsible for architecting, hosting and storage platforms. It was always an issue, and then how do we then within the operating system to a company that we're hosting solve that as well? So it's a double-edged problem that we used to try and have, and we could never really look at it. I mean, object storage was kind of the thing that people defaulted to solve that issue to a certain extent, but then to that, it still creates problems in terms of accessibility, duplication, access, speed of files, all that kind of stuff.
It was kind of this: if we forego any notion of high performance access, low latency access, if we say it's going to be low latency, then maybe we can solve the problem. But they really threw out the baby with the bathwater, because it was all in an attempt to be able to scale to web scale and host lots of data from many different companies in the cloud. So Amazon invented S3, super simple storage, 3 S's, which was really a dumbed down file system, not a real file system, not something your OS knows how to read and write to, right? Yep. So you have to change every last application in user space to talk to this thing over HTTP web protocols. So forget performance, right? And forget the rich feature set. I mean, you cannot even put your program binaries and libraries, your program packages on it and run from it. The OS can't load programs off of it.
Yeah.
Right.
Therefore, it's not a file system. It's not a file system.
It's not a file system. It was always a cop-out. And the cloud guys convinced the whole industry that, hey, if you want to go to cloud, the way you do it is you rewrite your stuff to use object storage. It's like all of that was because building file systems is so damn hard. And that's what we have done, though, is to build a file system that for the first time can truly scale and is standards based. And that happens to put the data movement function behind the facade of the data presentation. So now data can move transparently to the access and use of it. In other words, we make the presumption that data is always in motion, and we provide the vehicle so that you can consume it even while it's moving.
I get it. It's awesome. It's a great story. And hey, time's moved really quickly. I didn't even really realize how quickly we've gone through because it's been such a great conversation, right? But I want to finish up really talking about what you see the future for, the world that you're in and where you see it. The trajectory that you're on is crazy. But, tell me a little bit, maybe in 3 minutes or so, where
Sure.
Hammerspace is going, and where you see this data industry going as we continue to be connected, as AI takes hold and HPC becomes mainstreamed.
Well, I see a lot of disruptions that come by looking at what's going on at the high volume commodity consumer end of the spectrum. And our data as individual users on your iPhone or on your laptop or tablet, we have become accustomed to data being orchestrated. You don't even think about it. All of your data is at your fingertips no matter where you are. You can even lose your device and go buy one, and magically all of your data is there. Maybe because it's stored in the cloud or backups were stored in the cloud. It's all orchestrated for you. So if Hammerspace is successful in as little as 5 years, the industry is going to look back and say, how did we live in a world where we had to store and copy and merge data sets versus simply having data orchestrated for us to where it transcends the storage systems that are holding it, the same way your consumer data transcends the cell phone that's holding it at any one point in time. And it's the ubiquitous of connectivity that is the tipping point for both.
Love
Our
that.
cell phones are connected all the time now. We don't know what's on them versus the cloud. It doesn't really matter. Well, data centers and the world is so connected now that we can build an orchestrated, fabric to where data appears to be everywhere. And even this very high density petabytes of unstructured file data. So it was really only a matter of time before the infrastructure was capable of supporting it. And now with Hammerspace, we have the software layer to give you that facade of the omnipresence of data across all of the different data centers and in whatever system you need to consume it from at the highest level of performance of a supercomputer class file system. So the way I envision it, the world will soon forget the old days of copying stuff between storage systems, the same way we have forgot carrying floppy disks when we move from one laptop to the next, or
Yeah.
carrying thumb drives. We don't even think about that anymore. And you shouldn't have to think about that when it comes to enterprise file data or unstructured data generally. It should just be there on all of these devices and orchestrated for you.
Yeah, that's a great vision. It's a great analogy to use in terms of the mobile and what we do there. And I think from Hammerspace's point of view, and knowing now the specifics about your background and where you've come from, you know, I know that you are talking about something that is going to happen, right? And Hammerspace is right there to make that
It
happen.
will
So
happen.
yeah. And data, is so central to everything that we do today. I mean, I talk about that from a Veeam perspective. We protect the data. We love seeing data being stored in this easy way because it means that for us, we can trap it a little bit easier and manage it at that level as well. So there's so many good things here that we could still talk about. But I think it's been a great conversation about not only your history, but the history as to why Hammerspace exists. And I feel like you really gave a great journey story as to
Thank you.
the founding story of Hammerspace, the technology behind it, why it exists, and what it offers. So thank you very much for an engaging conversation. Just to wrap up, just as a final reminder, if you love great things with great tech and would like to feature in future episodes, you can catch us on social media at Anthony Spiteri or at GTwGT Podcast. Head over to the website gtwgt.com and subscribe. And once again, a heartfelt thank to you, David, for being on the show. Thanks to Hammerspace.
My pleasure.
And we'll see you next time on Great Things with Great Tech.
Thank you.